You are very brave because you are here to talk about C++ after lunch. And let's talk about some modern and cool things we can do with this old and cranky great language. About myself, my name is Jose. I work at Victoria Metrics as the product lead for cloud. We do have software as a service, so you can just go and try. I also work part-time at the university where I teach physics because I have this background in research. And I've been also working after that. I knew how to program in C++, so I started working as consultant and going to many companies. And then I ended up also managing these wonderful projects of the CNCF at Red Hat, in this case, Jaeger, OpenTelemetry, Kepler, which are great. And before as I said before, I went to the dark side of the product. I used to be a software engineer. And from time to time, I fool myself telling, hey, you can still do some C++. And I've also been playing heavy metal for many years and sim racing. So if you want to talk about those things, I would love that. And I was in April. Why this talk? I was in April attending this talk by Strustrup, the creator of C++, and there was this debate about, hey, why there is not so much traction of the language, even though it's everywhere. It's in all the game engines. I believe it's in ClickHouse as well, right? Also, it's in every operating system, right? But still, the language has evolved, but we all have this kind of thought like, maybe it's not that cool. Do you guys use it in production? Nobody. Okay. Yeah, I get that a lot. Me too, so I need to shut up. Yeah, totally. That's normally what we get, right? So that's why I was so excited that this talk got accepted. I'm going to talk about C++ and OpenTelemetry. Those are the two things I love the most in this tech. And of course, I started being bullied by my colleagues saying, oh, this language, I spent so much time trying to learn, it's useless, blah, blah. And then I tried to explain the best way to learn C++ in 21 days is just you will spend your lifetime until you invent the time machine, and then you will go back and replace yourself with all the knowledge, right? So this is C++ in a nutshell, I would say. What about OpenTelemetry? I guess you guys use it or know about it. How many of you use it? Because it depends on, okay. Maybe one of the reasons the adoption is not that high, even we are all talking about it, is because it's not that easy to implement or to include in your services. And this survey that is less than a year ago, it was published less than a year ago, said that people were complaining about, we don't have examples, we don't have a lot of coverage, even in the documentation, so the structure is bad because a lot of people is contributing, but then this has some downsides. That's one of the things. And also, people, for example, in Reddit are complaining, has anybody really been successful doing this? And in this case, I was very happy because I earned 2 karma points by giving my examples in Reddit, so at least it was good for me to some extent. Okay, OpenTelemetry. Let's start from the basics, and then maybe I can share some knowledge so you can start doing it by yourself. And of course, this is not only going to be in C++, I promise, so just bear with me. So OpenTelemetry, I just took this from their webpage, is these collections of APIs, SDKs, and tools that help you to collect or instrument or generate the signals, and the signals are metrics, logs, and traces. Okay, a lot of words, a lot of things here. Let's talk about it. But when you talk about observability, you think about these 2 kind of things. The first one is a cool dashboard. The second one, maybe it's a database. But you know what? OpenTelemetry is not about this. OpenTelemetry is about the other thing, which is what gives you value, I would say. It's about instrumentation. You need to generate those signals, so later you can use your cool AI on top of that, but you don't have the data. How do you do it? Again, when we talk about OpenTelemetry and modern instrumentation, we always talk about, hey, if you install this agent, it will be producing this data for you. And it will be using eBPF, which was cool before AI, right? But the AI happened. And you can do it as well with bytecode manipulation. If you use Java, it will just do it for you. And also, if you use Python, for example, it uses monkey patching. My point is there are many mechanisms in which this great project and big project helps you to instrument and generate a lot of data for you. So you don't need to touch, which is normally what your manager wants to hear. Okay, I can have this without really spending resources, people resources on that. Okay, so if you wonder how monkey patching works, just to provide one example, you have this library that is the mathematics library, and you say, hey, what's the number pi? You say, okay, it's 3.1415, blah, blah. And what monkey patching does is at runtime, which is the important word here, it will say, no, it's 3.2. So every time you call it now, it will be 3.2. So for OpenTelemetry, what it will do, these agents, they will configure your libraries and start using that, producing those signals for you because they were programmed for you, which is great for edges and libraries. For example, I'm using a database. I want to understand what happened there, right? Because I don't know. Someone else programmed it. This is great because then I can activate it. But the bad thing is that this is not for all the languages, right? For C++, it doesn't work like that. And it's not only because of a lack of functionality in C++, it's also because it's hard to control the data. It's not that good. It will imply a lot of cost, and maybe your performance will start be degrading because or your network will be producing data, or your databases will start suffering because you will have a lot of information. And at the end of the day, what we want to know is if my code is failing or not. I don't want, okay, this library, it's okay, but I don't want to fix that in the end, right? So that's why we need manual instrumentation. So all these jargons, all these flashy things are okay, but at the end of the day, if you want to do something right, you need to do it yourself. So let's get deep into it. I tried to add some jokes here and there, but please bear with me. I promise I think this can be interesting. One of the things that are the most interesting of the instrumentation or how OpenTelemetry approaches is that it decouples the API from the SDK. What the hell is that? In the API is just where, how do I call inside my code? Hey, I have this new measurement and I add it, right? The SDK is how I export it. So by decoupling, I can just touch my code without worrying where I send it. And if tomorrow I want to change that, I just need to change the SDK. I don't need to change all my code, right? So I will explain this in a second. I will explain metrics, logs, and traces. Bear with me. And metrics are the most difficult. At the end of the day, this is what I want to do, right? Hey, I have my code. I receive an error. I want to log it. I want to throw this metric saying, hey, I received one error from this other service. So this is what I want to do. How do I do this with C++, with OpenTelemetry? You go to the documentation, you start reading, and you say, okay, I have a meter provider, a meter, instrument, measurement, okay. And then I have the SDK, and I have a reader, I have a exporter, I have all these things. And then you say, okay, whatever, I will just log into the console. But it's not that hard. I have an interface. This interface will give me a thing that I will use to create my metrics, which is a meter. And here I define my instruments, which are my metrics. For example, my counter, right? The number of errors I received. Okay, so I just need my interface and my meter to create my metrics, cool, which are called instruments. And this is what we wanted. It's done. But again, we all fail to do this because it's a lot of terminology. So that's why I try to put these three concepts together. We achieved our goals. And every time I have a new measurement, a new event that happened, I will just create my map with my labels and all of that, and I will just throw them. Okay, this is a map. Again, meter provider is my interface. I will create the instruments I want, if it's an histogram or a gauge or a counter, whatever. And I will use them to record what happened. But that was the API. And this is where things get interesting, because I can do this in my code. What happens when I record a metric? What happens is that it goes to the memory, some aggregation store, and you can define, let's read them every minute, and let's export them to my OpenTelemetry collector. So this is the SDK. But where I really love this project and how it's done is that now if tomorrow or at the same time, I'm not using OpenTelemetry, I'm using a Prometheus or Victoria Metrics, and I will be just instantiating another exporter, and my metrics will be there for Prometheus to scrape them or any other agent. So now I have these two things, and I don't need to change my code, how I call every metric, just because I want to send them to a different backend because my manager went to some talk and he loved this new flashy database, right? My code stays like that. How you create it in C++, I give this for reference. You don't need to worry about that, but just to let you know, I define here my parameter. Hey, every second, let's send the data, and let's send it to this endpoint. And yeah, I need to do things with pointers. It's C++, come, it's okay. But again, the important bit here, I have this one function at the top called init metrics for OpenTelemetry, but I can make another one set called init metrics for Prometheus. And I will just use them. So this is how it looks like. We are now experts in instrumenting OpenTelemetry for C++, which you are all your most beloved language. You know what? It doesn't matter because this is not only for C++. The cool and the pretty thing about OpenTelemetry is that, or one of the 1,000 cool things that it has, is that this is a specification. You will use these concepts for any language you want. So this is defined, and everybody adheres to this. So this is why this is important, not only C++. Metrics. We have traces, logs, and a demo. Traces. Do you guys use traces? Who uses traces? Okay, have. Let me just make a very quick intro, because normally, at least those who come from old code, normally when you think of a trace, you think of a log debug. That is like very debug. But this is not it in modern observability. A trace is a collection of spans. So I have a trace ID, and I put a lot of spans underneath. Why? Like, why are you doing this? Or give me a second, I will explain why. And what is a span? A span is a representation of an operation. Logs and events are cool. Okay, this happened. But it doesn't give me this time dimension. It doesn't tell me when it started and when this finished. And this is what I want to track. When I send a request to a server, I want to say, hey, I started. Now I got my answer. And then say, okay, let's note it down. It went well, it went bad. And I can continue noting. So that's a span. Okay? I put a lot of attributes there. Why is this important? Because I have my distributed system, because someone read Kubernetes and put me in Kubernetes and threw me there, and now I need to handle all of this. I have a microservice in JavaScript, another one in Go, another one in Java, another one in C++, whatever. I need to understand what's going on here. And that's why these spans help me, because if I carry my context everywhere, I can then visualize this trace. You can think of it like an arrow, like you can see where it went. And you can then kind of paint it and say, aha, service A called service B, and this happened, and this didn't happen, and you can compare. So this is what a trace is. How do we instrument them? Again, the API, the SDK, it's the same. It's the same. It's simpler, I promise, because now I don't need different kinds of spans. In metrics, we had histograms, we had counters, no, here I have a span. I don't need anything. So this is how it looks like. It's a bit simpler. My trace provider, my tracer, and my span. I throw them to my processor and send them to the export. Cool. The same concepts, I will not repeat them. Just, hey, let's send metrics to this OpenTelemetry collector. Let's batch them every 2 megabytes. And that's it. Normally, I would recommend to create some auxiliary functions to create your spans, especially if you want to have them like, hey, this is the parent, this is the children, the child. So then I can have this sense and I can be propagating this trace ID. But again, the important bit, I have my code, I'm going to send a request. I will say, hey, this is an HTTP request. Another cool thing about OpenTelemetry. I'm going to send an HTTP request. Okay, how do I log this? How do I put this information? How do I put, okay, this request is going there, it's not going there, right? Okay, there is this thing called, in OpenTelemetry, called semantic convention, which is super powerful because you have a semantic convention and a working group for anything you can imagine. For CI/CD, for general things, for functions as a service, for messaging, for remote procedure calls, whatever. All these semantic conventions will help you so you don't need to reinvent the wheel. Here, for example, is the documentation for HTTP. So if I want to log a method in my trace, I just use the primitives given by the library and I will just call them. So I don't need to invent that. I just add it from the library. Here, as you can see, it's not anything defined by me. It's predefined for me. I just use in the library. Then, okay, I created my span, I send my request, and I wait. What do? I log my metric, or I send my metric, and I add an event, because spans are not only this clunky thing that I was showing, like this complex thing. It's also somewhere where I can add my events, and I can say, hey, I was here. Hey, this happened. Hey, today is Monday. I don't know. I can add that. So I am waiting. When I receive my response, I will set this went well, and I will record my status code, or if it went bad, I will say it went very bad. So it will flash in red when I see it. Okay? So that's not everything. We just need to propagate context. But again, context, this thing is standardized in the World Wide Web protocol. So I just need to create, the library will create for me, if you were wondering, right? Like, okay, this is C++, I have a server and a client, how these things travel, right? How these spans travel. You will add them as headers, but this is taken care of for you. But I think the first time I was playing with traces, how does this work? Like, I have my code in C++, how is this thing? So it travels with your message. It's injected. That's why we are propagating context. Again, I will not be bothering you with all the nuances of how you do this in C++, but it's just really, you just create a map and you just inject these headers, and that's it. For reference, a couple of functions. Okay, we are 2/3 there. Thank you for not falling asleep. I really appreciate that. Let's talk about logs, which are in the end, because we are all very familiar with logs. This is the very first thing we do when we learn programming is observability. It's hello world, right? We are experts in observability since we are born as programmers. And I'm here to tell you how you do logging with modern observability. Hey, I have my application. I will be sending via the OpenTelemetry protocol to my collector, and then I will send this to the database, and you will tell me, why shouldn't I just throw this to the console as I do? Since the very first thing I did when I learned programming was this. Now you are telling me to change that, right? If you allow me to convince you, right, we are talking about hundreds or maybe thousands of requests per second in many microservices. Maybe it's good if we can filter or batch them, or add in, hey, this log is coming from this container, and then I don't need to do it in my code. I can have someone from the outside just putting that, or transforming, or processing, or just throwing something to the garbage. That's a good reason. And it also helps to correlate based on this, as I was saying. Okay, give me all the logs from this time, give me all the logs from this container. I will show an example of that. And especially in C++, we always end up reinventing the wheel because there is not this standard way of doing things. And here you have a library done for you. So maybe, or even if, because it's trendy, just do it. That's one reason. In the end, I know you will be just throwing things to the console, right? I know. Even in that case, what you can do with OpenTelemetry is say to your collector, you will add this component called file log receiver. It will read from your console output, and it will be, and there you can filter bats and all of those. So you have many ways, of course, like in C++, you have many ways of doing things. Just use the one that you like the most. There are trade-offs. But here now you know how to do it. I will not bore you how to do this. You are experts already in instrumenting in OpenTelemetry and C++, so this is how you define your variables of your SDK, and it's really that simple. So you can start today doing it. It's, hey, logger, get my logger, debug, hello. The very last thing I want to kindly ask you to, if you are starting using traces, add traces IDs to your logs. So then your cloud provider or whoever can do their magic to correlate. This is where the magic happens. When people talk about correlation, and you need to, this is the real correlation. I am here adding, hey, my message, and then this is my context. This is how you add context. Okay, we survived. Cool. Let me very quickly, I will explain the setup. The setup on my demo is I have a client written in C++, a server mock written in Golang, and I am sending HTTP requests. Okay? And everything that happens I am sending all my metrics, logs, and traces to my OpenTelemetry collector and reading some logs and a lot. I am storing all of this in my Victoria stack, of course. Where can I be doing this? And I am visualizing everything with Grafana. The repo is there. If you want to just reduce the Helm chart, we will be uploading the slides. Yeah, that's it. Oh, I forgot to send my traffic. That's unfortunate. But I will, so as you can see, I'm not lying, right? I have even more things. So this first thing is my client. This second thing here is my server and a lot of observability things. I have a Jagger, I have a Grafana, I have an OpenTelemetry collector, Victoria logs, Victoria metrics, Victoria traces. Okay, let's take a look. And of course, because I just started, it's not seeing data. So let's start from the end and we will come back. Things that I can do. I can very easily, with this instrumentation, I'm just creating my metrics and my spans. I'm not doing anything else. Just with that, I can build my own APM with open source solution. So here, for example, I have my logs. This is my log from my server mock. And my server mock is saying, hey, maybe you don't see it because it's very small, but it's saying, hey, request received. Here I created this view that is called get debugging. So it's showing me get things. I can show you the query. This is the query I'm using in Victoria logs. So I'm telling, go to this container and give me everything that has a get, right? That's what I'm doing. And is that the log? No, the log, because it's OpenTelemetry, comes with all this information. So I know the container. Of course, in this case, I was filtering that, but I know the namespace, I know the pod, I know some identifiers, I know where the file, where they are taken from. So I have a lot of information already, just because I am using OpenTelemetry. Other things I have, without talking about metrics, here I have a distribution of all the latencies of my spans. And I didn't create metrics yet. These are only spans and traces. What else? I have a service map. Of course, I only have two things talking, right? But this is a service map. And I can as well check a trace. And in case you wonder how a trace looks like, this is how it looks like. Here I have, in this case, I have what I call a script, and I said a get, a put, a delete, and everything together, and I call it a script. So here I have all these things chained, and I am sending 10 requests per second, whatever. And the cool part is that here I can say all the span attribute. Was this an error? No. Request method, post. It went well, yes. And where is this coming from? It's coming from a C+ library. All the information from my SDK is included. And my events. At the end of the day, this is what I want, right? I want to check. So I send a request. 4 milliseconds afterwards, I receive my response. And here I have my body. So I have all that information. And it's together with what happened at the other side. It's tied. So here is more information, right? So this is, and so I am already having modern observability with just a few lines of code in C++, which is pretty cool. Let me go back to my dashboard because I want to show you some stuff. So that's about what I did with traces and how can I and logs. Here are my metrics. These are metrics. If you use Prometheus, it's the same. This is just OpenTelemetry, but it's the same. So you can see here my queries. Actually, I am fully in Grafana. I am telling this is a Prometheus, but it's a Victoria metrics. But it doesn't matter in this case. Right? And yeah, here I have all my. This is my regular request as I used to have it with my created metric. And yeah, and that's it. The last thing I want to show you is that if you remember, this is just in case it didn't work, is span metrics. And with this, we're done. I told to you about this APM, Application Performance Monitoring. I'm checking the latency, I'm checking all these things. You know what? Instead of doing this, what I can do in the OpenTelemetry collector is generating metrics out of my logs or my spans. So I don't need to do them in my code, right? This is the magic that happens in all these cloud providers. So this is the configuration from my OpenTelemetry collector. I will just create a span metrics connector and generate metrics and send them to my backend. That's the only thing I need to do. So in this case, I don't need to generate those metrics. They will be generated for me. And how does this look like? I was hiding some information from you. This is what I crafted manually. This, I did it automatically. So here I have my response time. Here I have my request times, response time per request. And here some throughput, right? The request sent per second. If you are curious about how these metrics look like, they are predefined for me in the OpenTelemetry collectors. In this case, trace, spans, metrics, and then per span. So this is just the magic that normally happens under the hood. You can do it by yourself with just 2 lines in the OpenTelemetry collector, if you have spans. So we came a long way. Last notice is, guys, you remember a hello world? This is how a hello world looks like in OpenTelemetry. Things are magic, but not that magic. So watch out, these things can be very expensive. As a summary, we learned that with C++ you can do nice and modern things. These are also for other languages. There is this very nice thing about decoupling the API and the SDK, and semantic conventions, and the OpenTelemetry collector can help us. In case you want to test these things in cloud, of course, I need to say this. I work here. Victoria Metrics has this service for metrics that you can use. So thank you very much.